Good morning or good afternoon. Welcome to Connection Wednesdays. The summer holidays are over and a new season of this series of live webinars can start now. For those of you who are not familiar with Connection Wednesdays, let me just mention that it's a series of webinars dedicated to design and code check of steel connections, mostly in it's for users of IDEA StatiCa connection software, but it can be also useful for all engineers who are just interested in steel connection design. Let me introduce myself. My name is Jana, and with my colleague Adam, we will present two interesting examples. But before we start, let me just mention one practical thing. You are muted by default, but you can send us questions via the panel in GoToWebinar platform. So please feel free to send us questions. In the first example, we will have a look at the customer project. It's a 3D joint, and it's made of 3 SHS and 4 CHS members. And in the end, we will have a look at one help desk highlight. This time it's default length of members. Now let me pass the word to Adam, who will show you the first example. Adam, we cannot hear you.
Oh, sorry.
Yeah, no, okay.
My mic was muted, so I just wanted to welcome back everybody to the autumn series of Connection Wednesdays. Hope you enjoyed the summer holidays, and let's get back to work. So let's start right away. I'll just start the connection software in IDEA StatiCa package, and we'll start modeling and designing the joint that Jana presented during her speech. So let's just pick some starting template so we don't start with blank screen. So I'll probably pick this one. That's the most similar assembly to my joint. I'll leave the default steel grade and bolt assembly, etc. I can change that whenever I want during the workflow. So let's create that project, and we can start modeling the geometry. So now I have one main tube and two tubular diagonals. Let me check that. This is profile CHS 168.3 by 8, and that's fine. I will leave this one. And this is 88.9 by 5. I'll leave this cross section as well. And I will just start redesigning the position and the assembly of the joint members. So I will change here the direction of the tubes. Of course, the geometry modeling is all free. You don't have to stick to any templates. That's the advantage number one of IDEA StatiCa connection, that it's all free. You can do anything you like. There are no limits. So I will now copy this member and position it here, and I will copy this one and just add minus to this beta angle and get it here. So I have this tubular hedgehog done, and I will add another member with this button. I can do it also here by right click on members. So let's do it like this. And for this one, I will change the cross section This is now invisible because it's inside the tube, but I'll show you in a second. First, I will change the cross section to SHS 70 by 70 by 5. Just pick one from the huge library we provide. Here it is, and definitely I didn't want it there, but I want it in a different position. So let's adjust that. Okay, this will be 0 to have it horizontal, and I will move it slightly downwards like this. Okay, another member, and then I will add another one, and those will be the SHS diagonals. So again, I will pick another cross section, smaller one, 50 by 50 by 4. And again, I'll just assign the angle to this one, and I'll move this one upwards again. Okay, and one more important thing, because this is going to be tension only diagonal, connected just with one bolt by connecting plate, I will change the model type here to tension and shear force only. So there are no moments acting on this member connected to the hole joint. Okay, so now just copy this one and change the angle -45 to have it on the other side as well, just to mirror it, and that's it. So geometry done. So let's move on. I will now move to the load effects, and I will now input the internal forces, the nodal forces that you calculate on your global model, either by hand or in other software for the global analysis. So just take the nodal forces and input them here. You can do it manually like this. Let me just input here normal forces only, because I'm lazy to fill by hand the whole table here, but I will show you how to shorten this process. You can of course import forces of your joint from an Excel sheet. So let's do that. Push XLS import, and I'll go to an Excel sheet and I will import the internal forces into my project. Just copy paste, click OK, and I have another load effect, another set of internal forces here, which I will calculate just in one analysis, both of them. All right, so internal force is set, and now let's design the connections of the joint. I will now turn off one of the load effects to get rid of the arrows, to have better view for you to see better the whole joint and things I'm going to do. And so I will start by connecting these tubes to the main beam. So I will simply weld them all together, and you can also access the operations to be set by right click. So I'll just right click on one of these tubes. I will connect to the other tube, and I will choose this type of connection, which is cut or a miter cut operation, and all is set already. it's welded by a butt weld. You can see how it looks. This is now intersecting, of course. It just does this cut of these two tubes and weld them together. Okay, I'll just do the same here to these tubes as well. Of course, you can add an operation. I'll show you that later on by right-clicking here or just clicking here on the ribbon. So now just right-click here again and connect it to the main tube by a fillet weld. So now this tube is cut and connected to the main tube. I'll just modify the parameters of this weld or this connection. There are no flanges, so I can turn off this weld. There's only web of the tube, and now the fillet weld is set as double fillet weld, which is doesn't make sense here. I want it only outside, so I'll just switch it here, and I will switch from the default thickness of the weld. Default is when here you leave the value as 0, then it's calculated based on the connected member thicknesses. But if you want to set your concrete value, of course you can do that. So let's set 4 millimeters of thickness. And now basically I will do the same for the rest of these tubes. So let's simply copy that and change the member assigned to these operations, and 4 and 5. Okay, all welded, all fine. So let's move on now to this part of the joint, connection of these SHSs. This will be another connection here. So now I will add an operation, and here you can of course choose one of those predefined, or you can define your own, let's say welds, bolts, plates, or anything by this set of operations here. But this time I will use the predefined stop operation. And this asks me now for the bolt assembly. I will pick 8.8 grade and M12 size of the bolt. Now, of course, I have to set the parameters of the operations, change from the main tube, which doesn't make sense here, to M6, which is this one. Now you can see some things happening here already. So let's just define the operation here. So position of the stop will be 200 millimeters, thickness of 10 millimeters. That's fine. I will change the size of the connecting plate or the end plate like this. The bolt assembly I've already defined, so just change the position of bolts like this. This is now looking like this, so I'll have to get rid of these 4 bolts inside. I'll show you in a second. And what else here? Of course, the welds again for SHSs, there are only webs, no flanges, so I can turn off this one, and I will just define the thickness here like this, 6 millimeters. And for the stop itself, which is this part of the connection, this member connecting the end plate and the main tube, you can have it from member, which is derived from the member you have set the operation for, or you can simply change that setting selected, and I will use another SHS of 90 by 90 by 5 So this is slightly bigger than the connected member. And as I said, now let's get rid of these bolts. How can we do that? We go to the editor of the operation, either from here, from the operation panel, or just right click on the plate and go to editor. Here we can see the bolt. So I'll explode the bolt group, and now I can delete any of them I like, just clicking on that, or I can also click here on the list and take the number. And I will probably delete these two as well, and I want to move these two, number 15 and 13, in the middle. That will be probably the coordinate of y 0, so I'll just pick it here, write 0 for number 15 as well, and I have it in the middle. So let's see, and now I'll do one more thing here to have a nice roundings of the plate. So I can add operation for the plate in the editor. I'll pick the rounding, and I will just click on all corners here. So I'll have the roundings all around the plate. Of the value 10 millimeters, that's fine. Just slight rounding. And let's see what happened. We have the plate rounded, bolts set in the positions that we like, and that's it. Okay, so let's move on. We have to connect this stub to the main tube. I'll choose just a simple welding operation, which is done by this cut operation. So I will select stub. It will be cut by CH, that's the main tube, and I will change the cutting method from bounding box to surface. And we have it there. Again, I will turn off the flanges and set the weld thickness to 6 millimeters. Good. Last thing, the connecting plate for this tension only diagonal. Let's add it there. So I'll add a new operation. I will pick this connecting plate. So now I have it here on the list, and I can choose it by picking one from the list, or also I can just pick it from the 3D scene by clicking on the member. So the connecting plate was added here, and I have to choose to which members or plates it is related and connected. So it's related to the stub, which is this one, and a member, CH, of course. So we can see the plate in position and welded to these two members I have just assigned it to. And again, we just continue modifying the parameters of this operation. So we can define the thickness, 5 millimeters, and the size of the plate. Then we continue with position of this connecting plate, 250, move it on. Good. And of course, we will set the thickness here, 5 millimeters for the tongue. And for the cap plate, the length of the tongue here of 80 millimeters. I'll show you here where it is. If I choose front, it's now on the bottom of the connection. I can move it to rear, which will be just on the top of it for better visibility. And now, of course, I set again the welds. Positions are okay, so I'll just assign 4 millimeters of thickness to all of them. And here I will change the bolt size. I will pick M16. And also I will move the bolt slightly towards the connection. Okay. So that would make it. And one thing again, I'll go to the editor and play a bit with these plates of the connection. Again, we can go or open editor by right-clicking on any part of the connection. So this cap plate, I'll just round again for all corners like this. You can also open the editor from here. So let's select now the thong, this one, and I will also add rounding here, just for corners 1 and 2, like this. So it becomes rounded here at the end. And of course, I have to get rid of this intersection here, and I want to cut this plate. So I will edit it, and I will add a chamfer operation of 50 or rather 40 millimeters. And now I have to pick the right corner. So let me try corner number 4. And that's the wrong one. So we can simply change that here, number 2, and that will be definitely the right one. Okay. So even if you do a mistake, it's just easy to fix it. And now this is done. And what for the other diagonal? Because I'm lazy, I don't want to set the whole operation again. So I'll just push copy, and I'll just change the main member of the operation to M8, and I have it all set. Everything I have done is copied to this member as well. The only thing I can do here is to change the position of the thong from rear to front to the top. So it will be similar as here. And so that's it. We're done with the design. I can turn on the load effect again. And now just let's calculate that and see the results, if we pass the code checks or not, if we would have to redesign the joint. And this now runs the finite element analysis with all its iterations and then the computational process. This would now take about, I don't know, 1-2 minutes, of course, based on your computer power. So I have this connection prepared with the results as well. So we cut the time of just watching the calculation being done. So I'll just jump to already calculated joint. This is what you get after the calculation is finished, and that is the overall, or the overview of the results. Something that we called a traffic light display. Here you can see the parts colored in green, gray, yellow, or if it didn't pass the checks, some of the parts are red. And this of course means the utilization or how the capacity of each part of the joint is used. And you can just browse the results if you go to the check tab. Now here you can show, or we can go through all the connection parts. We can check the checks for a plate, for bolts. If we, for example, pick one here and we want to study in details how it stands according to the code, you can also open the equations or formulas based on the code to see the detailed values, everything displayed. The same for the welds. Of course, here are the formulas as well. So I have just a problem with the display while the other project is calculating. But one more thing I want to show you here is that now you see the let's say display of the worst combination or load effect calculated. That is shown here, the extreme, and you can also browse each of the load effects or combinations that you have set for the calculation. If you change here for current, so this now shows you the load effect number 1. If you remember, that was only the normal forces, and I can switch to the load effect number 2. That was the more complex loading from the Excel sheet that I have just imported. So you can of course browse the results for each of the load effects here, and then of course you can just display the stress distribution or the heat map of the stress along the joint, and forces involved. And you can also take a look at the deformed joint. This is now a bit slower because here the calculation is still running. Yeah, I got a computer a bit stuck, but yeah, I think that's basically everything that we can take a look at. The last thing, of course, is the report. And here we get all the information. The report is again editable, so you can choose any part or anything you would like to have there or not, make it shorter or longer. You can export to Word document directly to PDF, and you can add the formulas, pictures, anything you like. And one more thing I wanted to show you, so we're running out of time. I have to give my word to Jana. I want to show you on our web page, there is a handy feature which we have here in the cloud section. If you would like to share your connection with anybody who doesn't have IDEA StatiCa and would just like to see the connection, you can go here to the web page of ideastatica.com, go to online project viewer, and here if you just send them the project file, they can load it here and display it and check, I don't know, and click on the profile, see the cross-section, see the weld information, see the shape of the plate and everything. And also you can click here to download this connection as 3D DVG and just put it into your advanced deal or any other software, any other drawing software project, just to have it there done. All right, so that's all from my side. I'll now give word to Jana. Who's going to show you one of the help desk highlights, one of the questions we got on our help desk.
Okay, thank you, Adam. So as I promised, in these few last minutes, we will have a look at one project from our help desk. And in such case, the user was confused with the result of the calculation, because when we run the analysis, you will see that the plates, of the I section will be loaded over the limit. The other parts look fine, but if we go to results and we display, for example, the deformation, we will see that the member itself failed. So when can such a thing happen? So usually we go to load effects, and we can display the diagram of bending moment by choosing the wireframe view in the top ribbon or under the top ribbon. And you can see that although there is a zero bending moment in the node, there is a huge shear force over 1000 kilonewtons. And IDEA StatiCa define the internal forces in the node. But of course, there's a relationship between the bending moment and the shear force. So if I have zero in the node, but I have some shear force, then the bending moment will grow based on the value of the shear force. So the longer or the farther we go from the node, the bigger the bending moment is. So in such case, there's an option to change the length of the member. Maybe if you use the version 8, you remember that in that version it was possible by user to change the default length of each member in the design, and this option is there no longer in version 9. We hid this, so because the users were sometimes trying crazy things with this option, and this default value should provide the best results for the check of the connection. So it's long enough to cover all the plates, but still not too long, because the longer or the farther we go from the node, the less accurate the internal forces are. So in most cases, this default value is really the best that you can choose. But sometimes if you want to try, or you know that the bending moment is not so huge in this end of the section, you can go to code setup, and you can see that in the last part, model and mesh, we have a parameter default length of standard member, and now it's 1.5 multiple the height of the largest section. So we can maybe change it to 1.0. Sorry, it's not correct format. I will just enter 1. And you can see that the member is shorter now. So if I display the bending moment in the wireframe view, you can see that the value is not so huge in the end. So probably it will work better now. Yeah, and you can see that the plates are fine. So you can, as I mentioned, you can change it, but in most cases, this 1.5 multiple is the best option. I can also show you that we have an FAQ for this in our resource center. So if I go to resource center and in geometry, the last question is, where is the definition of member length? So you can see and you can read more about this here. So I think that's all for this example. Maybe we can just shortly have a look at least one question. I'm not sure if we managed to answer all your questions, but we will definitely do that by email after the webinar. And maybe one question was about the import of internal forces. Adam, if you can do it some effective way in case you have more load cases to import.
Okay, so yeah, I understand, I believe. So if you would like to import more load cases from Excel to IDEA, if it's possible, and how can you do that? Okay, I'll take the presenter. Yeah. Okay, so I can show it here with this example. I showed you how to import one load effect or one set of internal forces. So in case we have, for example, 10, I will just quickly replicate this. So to create fake, let's say 10 combinations, or I don't know how many. So yeah, this is very possible. You simply copy the whole field from Excel. You go to IDEA and you paste it here, and it would just enlarge the tab, and it would sort those internal forces into the load effects. So yeah, this is possible like this. And then if you would have, for example, we had these questions a couple of times, if you would like to design your joint and you have, for example, I don't know, 20 combinations you need to check, and you just are in the first phase of design and you're not sure if the design is fine, and you don't want to spend or wait for a couple of minutes while all the combinations are calculated. You can simply turn off all of them and turn on just one, and run or analyze the primary design, then redesign the joint to the best shape, and then you can also again select all and calculate the joint for all the combinations. that's one trick in IDEA StatiCa you can do. All right, I think we're just over time, around 10 minutes.
Yeah, so thank you, Adam, once more. Let me take the presenter back, and I will just mention like a few last things. So, so after the webinar, we ask you kindly to fill a short survey about this webinar, and of course you will be also able to watch the recording from this webinar, and of course all other past webinars that we made. They are all on our web page and also on our YouTube channel. If you are interested in getting a trial version, please go to our web page and apply for it in the top right corner. And of course, you can go through our resource center where there are really a lot of information about the software, and we will prepare a next Connection Wednesday for September 19th. It means we will meet every other week till I think the half of December in this autumn season of Connection Wednesdays. So you can look forward to see more interesting examples of our customers, and also some webinars will be made by our colleagues from a UK office, so they have always very interesting examples as well. And now thank you for your time, and we are looking to seeing you next time. Goodbye.
Yeah, thank you. Have a nice day, and just keep in mind to be safe or brave. In IDEA StatiCa, it's better to be safe. Bye-bye.